It's a pleasure to be here, and I appreciate the opportunity. It's my first interaction with the Nebraska Sorghum Board. I am not a sorghum expert. I am a food engineer, but the goal of our research program is to advance the bioeconomy in the region by developing new technologies to transform the agricultural products and also agricultural byproducts into new value-added products to create new markets for the Nebraska agricultural products. And Nebraska is a great place for the bioeconomy research. There are a lot of agricultural products, and among them, sorghum is an interesting one. And in my presentation, I'm going to present one case study on our research, how we use sorghum and its processing byproducts to convert into new food or biomaterials. There's no need to talk about sorghum, but what we know, as I said, I'm not a sorghum expert, but what we know, two main applications of sorghum is ethanol production and flour production for food applications. And when we look at these processes, sorghum DDGS and sorghum bran, they are the side products from those two processes. We call them side products, but I hear from a lot of people all over the world, they may call it waste, but we never call those byproducts or side streams as waste, because there are a lot of good stuff in those materials. So our goal is to look into those byproducts and understand their composition and develop technologies, new approaches, and transform them into new products to develop new markets. So can we generate new value-added products from those byproducts from sorghum? And in the end, hopefully, they are going to support the sorghum growers, farmers, sorghum industry, ethanol industry, and also food industry utilizing sorghum. But the question is, how can we do this? How can we develop these new value-added products? So we believe that one solution is bioeconomy approach, especially circular bioeconomy, and developing innovative processing technologies. So what is circular bioeconomy? So currently you see this current linear economy approach. It is based on take, make, and dispose mantra. So what it means, we have a starting material, we take that material, let's say crop or any feedstock, and we use it to make products, and then we dispose it. So it may be called as waste. But in the circular economy or circular bioeconomy approach, we actually mimic nature. When we look at nature, everything is somehow recycled. Nothing is wasted. They go back into the system. So the circular economy here, the idea is to start with a feedstock, let's say crop, process it, obtain different products. It can be food product, fuel, or biomaterials, and then use the side streams or this waste that is typically disposed, put it back into the system to generate new products. So very briefly, we see a lot of opportunities offered by this circular economy approach. So as I said, this gives us an opportunity to redesign products. So rethinking and redesigning products to reduce their ecological footprint or convert them into new products. Supply of renewable energy like ethanol, and resource recovery from waste. It can be, again, energy, food, or different biomaterials. So in the circular bioeconomy, it's a big approach. Biorefineries, they have a critical role in the circular bioeconomy. So what happens in this bioeconomy? we have feedstocks, this biomass. It can be animal biomass or plants, crops, or the waste that stays on field after harvesting, anything. They are converted using some technologies. It can be current technologies or hybrid technologies or new technologies. They are converted into biofuels, bio-based products, food, or feed. So one more time, what is bioeconomy? How do we define bioeconomy? There are different definitions. I choose the USDA definition. It's a facility, including equipment and processes, that converts renewable biomass or intermediate ingredient or feedstock of renewable biomass into any one or more of a combination of biofuels, renewable chemicals, or bio-based products. Actually, biorefinery is the equivalent of a petroleum biorefinery. When we look at the evolution of biorefineries, we see that actually, biorefineries are older than petroleum refineries. So when we look at history, human beings, they use biomass for heating as energy source or making clothes, houses. So it's actually older than petroleum biorefineries, refineries. So in a typical petroleum refinery, we start with crude oil, and there is refinery that includes different processes and technologies converting the crude oil into fuels, materials, and chemicals. What happens in a biorefinery? It's the same thing, but our starting material, instead of crude oil, it is renewable feedstock. It can be different crops, woody biomass, agri-food industries, waste, even municipal waste. And in the biorefinery, similar to oil refinery, we have different technologies that convert those biomass into fuels, materials, and chemicals. There are some fast facts about biomass. And we see a lot of opportunities from biomass. First of all, it's versatile. There is value for waste. Many times, I have been working with different industries from New York to California. So they come with different wastes. So they are looking for waste to utilize. And oftentimes, they tell me that this waste is an issue for them. They don't know how to dispose it. Even just dealing with waste is an issue for them. Sometimes for storing, they need to dry it. It's spoiled, it creates a lot of problems for them. So they are looking for ways to understand the composition and how can we convert these products, these waste, into high-value products. And we are seeing there's a lot of economic benefit. It is possible with this waste, and it is abundant also. So here in my presentation, as I mentioned, I'm going to present two case studies. How do we use sorghum and sorghum byproducts to generate new products for food and material applications? Here, we have been working on different sorghum feedstocks. What I mean, the whole sorghum grain, byproduct from ethanol industry, and the DDGS, and the bran from the sorghum flour production. And we obtain wax, which is a natural wax from sorghum, and fat replacers using sorghum wax. So these are two products. There's a lot of demand in industry. I will briefly, without giving a lot of technical details, I'm going to show you how do we do it, what approach we use, what is the potential. So I don't know if you are aware of the wax of sorghum, but on the outer surface of sorghum grain, there is a waxy coating. So we found a way to utilize this wax on the surface. And our approach was, can we selectively isolate this wax from the sorghum so that the remaining part can still go to food production or feed production? Or can we isolate this wax from ethanol industry's byproducts? So, as I said, this is a natural wax. Here you see the applications of natural waxes. So they are used in car polish, especially carnauba wax is used in those car polish, and when you use that wax, I believe the price is higher for that car polish, that is a higher quality. It is used in coatings, it is used widely in food packaging, in cosmetics and personal care, pharmaceuticals, furniture coating, candles, again foods, in those even those jellies, this wax is used. And I looked for some information on the market size of wax. Looks like there is, even based on our interaction with industry, there is a demand for natural wax, and it is growing globally. And when we look at the carnauba wax on the left bottom corner, which is one of the main natural waxes used in industry, and it is anticipated that the demand will grow due to different driving forces in different industries. And we know that there's a need for natural wax. So typically, you can obtain wax from petroleum industry, but if you are going to put it into a food product, or if you're going to use in food packaging applications, you want a natural wax. Where do we get those natural waxes currently in the United States? Two major waxes are carnauba here and candelilla waxes. They are imported from Brazil and Mexico. So United States mostly depends on the imported waxes. So can we give independence to United States in certain areas for wax? Can we generate our own wax? So there is a potential here. Of course, it requires further research. And we know that the applications of natural waxes are increasing. But the supply of those natural waxes, is not stable, and the prices keep increasing. And we are proposing grain sorghum as a promising alternative to obtain that wax to replace carnauba and candelilla waxes, especially carnauba wax, for different applications. But there are challenges, of course, here. First one is lack of information on the effect of sorghum feedstock on the wax extraction. As I mentioned, we have grain sorghum, we have sorghum DDGS, and the brands. So how do you develop your technology? Based on what feedstock? What are the effects? Because the compositions of those feedstocks are different. And the absence of a separation process to obtain pure sorghum wax that meets natural wax industry specification. This is a challenge. Separation processes are always a challenge, and especially if you are dealing with food products, or if you are trying to obtain something that can be used in foods, it makes it more difficult. And this clean extraction method, that is what we hear from industry all the time. They are looking for something clean. They have their own driving forces. Their customers looking for something more clean process. So what we do here, we use those three feedstocks, and we isolate wax using carbon dioxide. So the technology we use, its name is supercritical carbon dioxide. I will briefly introduce the technology to you, and here you see the products obtained from the extraction process. The first step is extracting wax from those feedstocks using some solvents. Typically in industry, hexane is used. Hexane is obtained from petroleum industry, and it is highly flammable. When you talk to industry, they don't like hexane. They try to replace hexane with something non-flammable because it's very dangerous to work with hexane. And many manufacturers, they prefer something clean so that they can label clean product or they can label organic. As I said, there are different driving forces for industrial product manufacturers. So for that purpose, we are using this technology. And right after this extraction, we have a simple cleaning process where we use ethanol to obtain a high purity sorghum wax, where you see these three products obtained from bran, DDGS, and the whole kernel. Very briefly, without a lot of technical details, what is supercritical carbon dioxide? First of all, it is carbon dioxide. We know matters how we have solid, liquid, and gas. This is the phase diagram. What it means, depending on pressure and temperature, your water, for example, will be solid, liquid, or gas, right? But actually, there is one more phase here, which is called supercritical. That means if you bring the pressure and temperature of a fluid, gas or liquid, into this region, it is going to be supercritical. That means it is not solid, it is not liquid, it is not gas. So it is a completely different environment, and we change the properties of carbon dioxide completely. Now it is not a gas. We can do a lot of different things with carbon dioxide. It is a very simple technology. You don't need to deal with a lot of solvents. It doesn't generate any waste, and you can develop different extraction systems even in farms. And you can operate it. Here are the advantages of this technology. First of all, it's non-flammable. It is replacing or an alternative for some processes for hexane extraction. Hexane extraction is still used in industry, but for some special applications, this is being used. It is, as I said, it is inexpensive and harmless. And at the end of the extraction, there is no solvent. Because when you have solvent in the process, that means you increase the cost. You have to transport, store, and after the extraction, you need to separate that solvent. The separation requires extra energy, additional unit operations, and you need to store that back. And as I said, it is dangerous. And the process, it is a low temperature process. We always prefer low temperature processes in food or biomaterial processing. Here are different applications of this technology. It's being used in food industry. Pharmaceutical industry really loves it, and cosmetics and different special applications. Here you see some food products on market. There are hundreds of them, and some of them they put on the label, it says extracted with supercritical carbon dioxide. Typically these are much higher quality. There is no safety concern for consumers, and if it's a food product, the taste is better. Here are some applications. We have supercritical carbon dioxide extraction plants in the United States as well, but these are some, these images are from my collaborators from Austria. They are building these large plants all over the world. So first one is, decaf coffee. How do we produce decaf coffee? Somehow you need to separate caffeine from coffee. This is one technology. We have products on market, and they put on the bottle, they say decaffeinated using carbon dioxide. Another application is spice extraction, especially in Asia. There's a lot of spice production, and this technology is used there for spice extraction. Hops and nutraceuticals processing. This plant is from New Zealand. I know there's a lot of interest in hops in Nebraska, and there are some sensory panels showing that when you obtain hops extract with this technology, the taste of beer is much, much better. You eliminate some heating processes at the end, and this is a superior quality beer. And this is a rice treatment plant from Taiwan. They remove the pesticides from the surface because you have a grain, you don't want to soak it in water or any liquid thing. Because this is like a gas, it just takes the pesticides from the surface and leaves the product. You don't have to do anything else. You have this clean food-grade product after processing. And another interesting application is cork cleaning, wine cork cleaning from Spain and France. So after, consuming the wine, they clean those corks using this technology. Again, it's a very simple process. You treat it with this carbon dioxide, and then there's a valve. Once you open the valve, CO2 leaves, but we recycle the CO2. We don't release to the environment. It is used again and again, and you have the product. So here, in our process, simply I compare the conventional process to obtain this wax, and when we use our supercritical extractions or carbon dioxide extraction and additional ethanol wash. So there's Lauren Isom here from the UNL Industrial Agricultural Products Center. Actually, this is how we started. He came to me, and they were interested in it, so they knew this before me, the wax. And looks like they went to a toll processor in industry, but they were not able to obtain a pure wax sample. It was liquid, there was a lot of oil, so we worked on it. Can we obtain a pure sorghum wax? And in the end, when we compare, this new process is very simple, and just 2 processes, and you don't have to deal with a lot of waste. And in the end, you can obtain dry, high-purity sorghum wax, which is not possible with this conventional technologies used in industry. And here on this graph on left, you see the yields after extraction, how much you obtain. Hexane is the industrial solvent used. There are large hexane extraction plants. And here you see this taller bar, supercritical carbon dioxide. We obtain better yields with this technology. But one advantage here is when you extract this wax with hexane, you cannot use let's say you have the whole kernel, whole grain. You cannot use it for food production after wax extraction. But once you separate wax with carbon dioxide, you can use this product for food application. So you separate the wax, the whole grain can go to food production, which is not possible with this hexane extraction because carbon dioxide just takes the wax from the surface, and because it is food grade, it's clean, it can be used for food or feed applications or other applications. So here, I'm just going to show this 1, 2 lines. So what do you see? We have a special equipment that determines the melting behavior of materials. For wax, melting behavior is the most important property. Here, you see this is carnauba. So we want to obtain, if you propose something to replace carnauba, melting profile must be similar to this one. And you see, this is sorghum wax. Actually, it is even better than carnauba. This is what we are looking for. And here, this table shows the comparison of some critical properties used in industry when they determine the quality of the wax. You see candela wax, carnauba wax, and this is our product. And after this simple process, we can obtain something comparable to carnauba wax. Another application is fat replacers. So this is a new product that can be obtained from sorghum. Very briefly, fat replacers, we use fat in bakery products. They give a lot of good properties to baked foods. So if you want to obtain a good baked product, you need to obtain those solid fats like butter, or they are called shortenings. But there are also some disadvantages in terms of health, and consumers trying to avoid them. And therefore, industry is looking for alternatives, especially in 2015, use of partially hydrogenated fats were banned in the United States. That means trans fat causes health problems. So how do you find alternatives? So our proposed solution is converting liquid oils, healthier oils, into solid fat structures. And this market size shows that there is growing interest in fat replacers, and this is what I hear from my industry collaborators, used in different food products. What do we do here? Again, it's a very simple process. We have a liquid oil, any liquid oil, doesn't matter. When we add sorghum wax in it, and when we apply ultrasound, even simple mixing will work. As you see, we don't use any additional chemical. This liquid oil is converted into solid fats. So these inverted vials show that they are solid, they are not flowing. So they can be used in different food product applications. And here you see we tested them in some cakes. This one is butter on the left, and these are the ones prepared with sorghum wax-based fat replacers. And that means this product can be used in industry as saturated fat replacer. So this in the end, so these are the anticipated outcomes and impact. Hopefully, this approach will generate new value-added products from sorghum and full utilization of sorghum and their byproducts. It has the potential to create new market opportunities and economic benefits for Nebraska farmers, and hopefully it can contribute to job creation and rural economic growth. Before finishing, I added one more slide, which is not related to this, but I mentioned Lauren is here from UNL Industrial Agricultural Product Center. So we are currently trying to establish a new center at UNL to support the advancement of bioeconomy in Nebraska. Nebraska is a great state for bioeconomy. It's an agriculture state. We have a lot of talented researchers, farmers, and the goal is to convert crops or animals or their byproducts to value-added new products. And hopefully the idea is to draw investment to Nebraska's bioeconomy, add value to Nebraska commodities to increase to benefit the farmers and generate new jobs in biofuels, bioplastics, or specialty chemicals and food, and also, which is important, to develop skilled workforce for careers in biotechnology, bioengineering, and manufacturing. With that, thank you.